All right, guys. So what we've been doing so far, this first one here, this A, linear x, y, that's the stuff we've been doing in Unit 8. Okay? Where it's actually linear regression. We wrote our little y hat equals b sub 0 plus b sub 1 x. Hopefully you know that since your test on that is kind of sucks, okay? We know that. All right, these three are what we're going to talk about for Unit 9. What we're talking about with these different models, we've got power, exponential, and logarithmic. That means your data set is not linear to begin with, okay? It looks like one of these. And then you want to straighten out your data. You want to make it linear. So you have to do some sort of transformation to your data. So that's the goal at the beginning here. We want to transform data so that linear regression will work. In Unit 8, that was always supposed to be the first thing you check, like, is the data linear? Like, does it make sense to use linear regression? And the answer was always yes in Unit 8. Unit 9, it will not always be yes, and you'll have to think about how to straighten it out. So, all you end up doing then is applying one of these options. You either take the natural log of your x values or the natural log of your y values, and then use some sort of combination of those options for your x's and y's. So if you take the natural log of both, your new equation looks like predicted natural log of y equals b sub 0 plus b sub 1 natural log of x. Exponential is going to be predicted natural log of y plus b sub 0 plus b sub 1, and just x. You guys see how this time the x we're leaving alone? And then the third one, the y, we're leaving alone, so it'll be predicted y equals b sub 0 plus b sub 1 natural log of x. Okay, so you are just figuring out which one did I use. Or is this my new x and y? Did I keep the x and just do natural log of y? And you're just substituting them into the equation where they go. It's not complicated. And your calculator is going to do all of this for you. You don't have to actually do the natural log of each point in your set. You're going to look at how you do it. So go ahead and turn the page for me. I know, I don't know why Ellen but that's a separate question. All right, guys, so step 1 and 2 here, that was Unit 8. You are used to doing that. You can put your lists in, explanatory, your x in list 1, response variable, or your y in list 2. Make your scatter plot, look at it. Is it linear? Is it not linear? Okay. The rest of it is the new stuff. So to do this, your list 1 is going to be your x values. List 2 will be y. List 3 will be natural log of x, which is really the natural log of list 1. List 4 is the natural log of y, which is really the natural log of list 2. Does that make sense? Okay, so let me just show you on your calculator what that does or looks like. Maybe. See if my calculator wants to open. You guys don't have to go through this, but let's just say I have some values right. Okay, so I've got my points. You could certainly look at your scatter plot. It's not really going to matter with what we're doing. Okay. Not looking super linear, right? So, so what we're going to do is go here. I know that I want to take the natural log of some of these variables. So what I do is just natural log, and then of list 1. Okay, that was my x's, right? Where am I going to store that? List 3. Okay? Yeah. And then I also need to take the natural log of list 2, because that's my y's, and I'll store that in list 4. Okay? Make sense? So if I went back in and looked at my lists now, see how I have a list 3 and there's going to be a list 4 after it? Like, it's just done for you. Your calculator's very helpful. The reason we do this is then we try to decide which regression model is going to make the most sense. So what you're going to do is go through and calculate your regression. So that was number 8 for us, I believe. You can do the original one with list 1, list 2, calculate. And you're going to look at the correlation to see how high that R-squared value is, or the R, doesn't matter either way. Then you're going to go through and do it. Okay, I'm going to check it with, let's see, I don't know what order I wrote them in. I can go through the power next, where I use natural log of x and natural log of y. So I'd be doing list 3 and list 4. Calculate it, see where the correlation coefficient is. Yeah. What not the right thing? Because we want to make it here. This would give the curve. Yeah. Yep. And you just change what your lists are. You can do list 1 and list 4. Leave the x alone, do natural log of y. You can do list 3 and list 2. Does that make sense how you're plugging in the different options? Okay. We're going to practice one too. But that's all you're doing. So you're just going back through and figuring out, like, okay, is that best? Is that best? Is that best? Is that best? All right. And just looking for which one is the best fit, like makes it the straightest. It is. It doesn't, I mean, they both tell you the same thing. Closest to 1, or -1 if you're looking at the R. Okay? Yeah. You could. So, like, that's what we're going to do. We're going to practice one. So if you look at the next page, guys, we're given this set of data points. And you have to pick which one gives you the best straightening, in a sense, of your data value. So I would just go through and make a little chart and be like, okay, so I know when I do linear, I'm talking about x, y, and then make a column that is, I'm going to do R-squared value. But just go through each one, be like, okay, power. That's where I do natural log of x and natural log of y. What's my R-squared? Exponential. That's where I do x, y, and log. Y. So I just want you to go through each of those and jot down your R-squared value for each. We know the linear one's not going to work, but we can still jot down what our R-squared value is for that. So I know this is going to take you a minute to enter in your data into your list 1, list 2. take your natural logs of those, and then we'll look at how you did. Okay guys, remember, you are calculating linear regression every time. I know these points do not form a line. What you're doing is trying to transform the data points so that it is linear. Okay, that's why we're doing these transformations of taking natural logs of things. Okay? But then you still pick linear regression every time. Just run through it with L1, L2 would be linear. L3, L4, that's if you're doing natural log of X and natural log of Y. L1, L4, L3, L2. Like you have to go through the different options of it. Okay? If anyone is struggling or doesn't know what I'm talking about, let me know. I'm going to write in your R-squared values that you should have got. Yeah, that's fairly strong. That's why you want to look at the scatter plot. Like, I mean, you could have argued, like, oh, that's straight already. Because of the way those points are, like, where these are so close together, you know, they almost look vertical there, and then these are so far apart. Like, look at your Y values. You're going from 3 to 103,000. So, like, not the most clear. Or, I'm sorry, your X values. Okay. All right. If you did not get those R-squared values, raise your hand so I can come and help you.
You got a wrong box.
Yep.
No, she mixed up the expensive model. I don't understand how she does that.
It's a good question though. I just gotta flip the X and not box. Because I don't know how
Yeah, so I would just make sure it's right. What we did is we scored.
It's not be that much.
Yeah.
It's 5 points. Yes, the rest of it goes to 1. If it was a 1 point quiz, I wouldn't worry at all. This 5.
Oh, that's good.
You guys okay? Stressful?
It's very small.
Okay?
Yeah.
You took it and you knew you couldn't even know what it was until like the next class or the next 2 classes. You could check on
Then there was always the people who would go on the middle of the day.
All right, so let's think about our model here. Is everybody okay with this one is the best fit, the power model? And it's not that we're using a power model because we're using linear regression, but the transformation following that, okay? So when we actually write our regression line, we write natural log, number of species, with a hat, because that's the predicted number of species, equals 0.76 plus 0.32, and I wrote too big. I gotta rewrite this here. Oh. And then this would be natural log of area. Do you understand where I'm getting the 0.76 and the 0.32 from? Your calculator found those for you if you did the regression with, in this case, list 3 and list 4. Okay. All right. Yeah. It's not going to be a huge part. There could be a question somewhere along the way. You know, like, the options, like, as far as the combinations you could have. Like, that part's easy to remember. The names, I agree, are not easy to remember.
Will we ever have to like say this is a power model?
That's just what he was asking.
Oh.
I'd be familiar with it, though. All right, guys, so let's look at part B. So we now have to use that model that has natural logs in it to make our prediction. So, natural log, number of species, predicted that it's equal to 0.76 plus 0.32 times the natural log of 436 this time, because that's how many square miles we're looking at. Okay, we have to revisit some of your prior math knowledge here. All right, so if you use your calculator, you get something like 2.685 on the right side there. I had a lot of you in pre-calc, so you should know how to solve that. No, so that's the natural log of the number of species equals this 2.685. I want to know how many species there actually are. What do I do? You use an E, yes?
Everything in the power.
Okay, you exponentiate, yeah. So we end up with E to the 2.685 equals number of species. Remember this? Yes, okay. Then it's just a matter of doing that on your calculator. And I think we get like 14.66. So you probably want to tell me either 14 or 15, because we can't have like part of a species, right? Not fun.
Yeah. I mean, those numbers, I don't think we could.
No, I know, but just in that we had to work with these.
Does that make sense?
No,
Yes? Okay. Questions on any part of that?
it's not like somewhere in my life I'm gonna be.
Yeah, you should. We'll do it that way. We'll say we predict.
What if you don't have?
What?
Like, name me a workplace where you're gonna do math and you won't have access to a calculator. Exactly. Why am I doing math?
You're in the middle of the desert.
I don't think.
Then why am I doing math in the middle of the desert?
Oh, if you're in the middle of the I mean, if you're in a situation where you find yourself stranded.
And I have to do math?
Yes. To
I
figure
think
out
I'm
how
trying
to
to, I think I'm trying to figure out how to survive rather than doing math.
No, to how to get.
Taking this paracord and figuring out
You
what
have
to
to
make
like
it.
long division or something.
No.
So guys, I'm just putting it back in context. We're predicting there's about 14 or 15 species when the area is 436 square miles, okay? Okay guys, so that is all the linearizing, transforming your data to make it linear. We still have to do the confidence interval and the hypothesis testing for slope. But those are familiar concepts to you, so it's not too bad. So let's turn the page.
That was conversation we just had.
That's not your next page, is it?
That whole conversation could be on
Collins and Lewis.
All right.
I bet he's really watching.
Whole conversation. About calculators and math. Being stranded and having to do math. Like, from morning.
Well, I
How do I know? Because I know how much. Where am I getting it straight?
All right, guys, this is your next page, right? Okay. All right, guys, so we're going to do confidence intervals. We're going to do hypothesis testing. You still have to write, and that should be a subscript, and it's not. Your null and your alternative and symbols and words. Hey, guys, stay with me here, okay? We have 10 minutes left. Did you get a packet? Okay, perfect. All right, so like before, we have to identify our statistics. We have to check some conditions. Conditions are slightly different. Your residual plot is going to account for almost all of the conditions you have to check. We're going back to using t-statistics when we're talking about slope of our regression line. Confidence interval, it's very similar to what we did before. This time, though, we're talking about b sub 1, so the slope of your statistic that you're looking at. Still have your t-crit, still have your standard error. Hypothesis testing, we're doing the t-statistic, b sub 1 minus beta over standard error. Like, that should all look somewhat familiar to you. I know we're using slightly different symbols because we're talking about slope now, but the idea of these should be familiar. Degrees of freedom, just a little different when we're doing this. It's n minus 2. Then your conditions. Let's look down here at all of these conditions. Okay. And then things didn't line up very well. So these first 4, those are all accounted for by your residual plot. So what you're going to look at there is for your residual plot to be cloud-like. Random is usually how you're going to say it. So a randomly scattered takes care of all 4 of those. So takes care of these. You do have to write linear, independent, normal, and equal variance. Okay. It spells line. That helps you remember it. Okay. Liner, if you throw random in at the end. So random is still the same. You just have to say it's from a randomly gathered sample. So usually it'll be stated or assumed from the random part. So these 4, you're just going to look at the residual plot and make sure it looks like a cloud. And as long as that's the case, then all 4 of those conditions are met. So I know it's a little confusing the way, especially these 2 are worded and written. You just need to understand the residual plot being scattered takes care of that. Yes.
Can't we just say residual plot cloud, not have to write any of those? Except for the random
You write
line.
linear, and that's liner. That's funny. I spelled that wrong. Independent, normal, equal variance, and then next to it, bracket, residual plot, random, covered. You have to write those 4. If you don't write them, you're not going to get credit for checking the condition.
I write
writing line, is it line?
It's linear. I don't know why I wrote it. It's getting linear.
So do we just didn't write anything about the linear?
No, you just have to write those words, the bold words, and then the residual plot takes care of it. Okay. All right. Stop there. I'll give you guys 5 minutes. Okay. You're welcome. So